here. So this example is going to look at how we can find the coordinates of stationary points on a curve and how we can classify them as being maximum points, minimum points, or horizontal points of inflection. And through this example we'll see two different ways that that can be done. So the first thing to do when you're trying to find a stationary point is to differentiate. If we work out dy by dx here, we'll get 4x cubed minus 12x squared, and we know that when the dy by dx is equal to 0, that's where we get our stationary points. We will, to classify the points, need the second derivative, which is d2y by dx squared. That's 12x squared minus 24x. So that's our two bits of differentiation completed. Now let's try and find where the stationary points will be. So the stationary points are when dy by dx equals 0, meaning that 4x cubed minus 12x squared is equal to 0. So to solve that, I'll take 4x squared out as a common factor, giving me x minus 3 in my brackets afterwards, which means that x must be equal to 0 or x must be equal to 3. From that, I can substitute those numbers into my original equation for y to work out what the y coordinates would be linked with those x coordinates. So if x is 0, subbing that into there, I get 0 to the power 4 minus 4 times 0 cubed. That's just 0. So 0, 0 must be one of my stationary points. Or if x is equal to 3, then substituting 3 back again into the y equation will give me minus 27. So 3 to the power 4 minus 4 times 3 cubed. Now that I know where I have some stationary points, I need to determine whether they were maximum points, minimum points, or points of inflection. So let's have a quick look at doing that. If we take the point 3, negative 27 first of all, so at that point, I can see that d2y by dx squared would be equal to, if I substitute 3 into this, I'll get 12 times by 3 squared, so 12 times by 9, minus 24 times by 3. And most importantly, I want to determine, is that going to be positive or negative? So 12 times by 9 is going to be greater than 24 times by 3. So basically I know that this is going to be a positive result. If that's a positive result, then it means I found a minimum point there. Okay. Now I need to go to the second point, so the point 0, 0. If I do d2y by dx squared here, then I'm substituting the x coordinate of 0 into d2y by dx squared. That's equal to 0. That means the test is inconclusive. We can't determine what sort of point we have in that situation. So we have to then go to the gradient test instead. The way the gradient test works is we think about the values of x just before the turning point. So if we think our stationary point was at 0, we'll think about what happens before, what happens afterwards with the gradient, and we'll be able to then determine what sort of stationary point we have. So if we imagine putting a number that's less than 0 into dy by dx here, let's say for example putting minus 1 into here. So if we put minus 1 in, we'll get 4 times minus 1 cubed, that's minus 4, minus 12 times minus 1 squared, which is still minus 12, so we've got minus 16. Most importantly, again, it means I have a negative gradient at that point. At the point when x is 0, the gradient is 0, and now let's see what's happening after that point. So again, imagining a point, let's say 1, if we put 1 into there, 4 times 1 cubed is 4, take away 12 times 1 squared, so 4 take away 12, that's minus 8. Again, that is negative. So I can now see that I have a negative gradient before, that means it's sloping downhill, then I have a 0 gradient there, horizontal, and then a negative gradient again down there. That would suggest that I have a horizontal point of inflection, and one with a negative gradient before and afterwards. So to determine that point, we will call it a horizontal point of inflection. Now, sometimes it's a good idea to get a sense of what this actually looks like if we were to try and visualize it. So you could test this out on your GDC, see if when you graph it, if it looks like you'd expect it to. But we've actually got enough information here to have a pretty good sense of what it would look like for ourselves. If we just quickly sketch out some axes here, we saw that we had one stationary point at the point 0, 0, and one stationary point at the point 3, minus 27. I'll put that down here. If you remember, we said that the point here was this horizontal point of inflection. That means it must have that kind of shape going through it. And then it must drop down, and we said that this point here was a minimum point. So we've got a rough indication here at 0, 0 and at 3, negative 27 as to what those features look like and roughly what the shape of the original curve y equals x to the 4 minus 4x cubed actually looks like.